Hello, hello. Welcome to Solving Linear Inequalities. Today's objective is to graph and solve linear inequalities in two variables. So here we're given examples of two inequalities, and we're given a point that we're trying to figure out whether it's a solution to that inequality. So what we want to do, for example, for A, we're given this point 7, 3. Now we want to test whether that point is a solution to the inequality. So all we do is we take this point, we take the x value, and plug it in for this value here, and take the y value and insert it right here. And we see what the results are. So if we exchange the y with a 3, we have 3 is less than 7 minus 1. Now if we simplify that out, we're left with 3 is less than 6. Now, that is true, so therefore 7 comma 3 is a solution to the inequality. So if it's true, it is a solution. If it's false, it's not a solution. Let's try example B. So for example B, we have 4 comma 5 for the inequality y is greater than 3x plus 2. So same idea. We take the value of 4 and plug it in for x, and take the value of 5 and plug it in for y. So that leaves us with 5 is greater than 3 times 4 plus 2. So we have 5 is greater than 12 plus 2. Now we obviously know that 5 is not greater than 14. So this is false. So we know that 4 comma 5 is not a solution to that inequality. Alright, well it's great to be able to solve that algebraically, but we should have a good understanding of what that means graphically. So let's look at the first inequality, y is less than 3x plus 4, and let's graph this. Alright, so I'm going to start off by drawing my y-axis and drawing my x-axis. Okay, so we want to graph this the same way that we would graph a linear equation. So think how you would graph y equals 3x plus 4. Okay, so let's graph that. So we know the y-intercept here would be positive 4. So we do 1, 2, 3, 4. So we have our y-intercept there, and our slope is positive 3. So that's a rise of 3 and a run of 1. So we go up 3, 1, 2, 3, and over 1. And then from the y-intercept, we go down 3 to the left 1. So 1, 2, 3, to the left 1. Okay. So here is our line. Now, since we're graphing an inequality, that means that these values aren't exactly on that line. So the way that we represent that is we do a dotted line. So we do a dotted line if it's a less than or a greater than, and if it's less than or equal to or greater than or equal to, like this one over here, that would be a solid line. Okay, so the first step is to graph it as if it is a normal linear equation. Second step is to decide whether it's a dotted line or a solid line. And the third step is shading. So put a 2 here that shows the second step. For the third step, it's determining the shading. Because these inequalities show a range. It's saying, well, it's all the values either above the line or below it. Now, in order to figure out which side, left or right, to shade, I like to test out a point. Now, to make our lives easier, we can test out the point 0, 0. Now, when I say test, I mean we're going to take 0, 0, and we're going to plug it in to that inequality to see what happens. So if we do that, into the equality y is less than 3x plus 4. If we plug that in for y, that's going to give us a 0. Then we're going to have a less than 3 times 0, which is just 0. And then we're going to have a 4 here. Now, is 0 less than 4? It is. So we end up shading the area that has the point 0, 0. So this point right here is in this range, so we shade this. Okay? And those are the three main steps. We write the equation as a linear equation on a graph. We draw a dotted line if it's less than or greater than. We draw a solid line if it's less than or equal to or greater than or equal to. And then for our third step, we do some shading, and we pick a point and we test it out. Alright, so let's try part B. So for part B, our linear inequality is written in standard form, and to make this a little easier to graph, I'm going to change it into slope-intercept form. So to do that, I'm going to subtract 3x from both sides. So I have 2y is greater than or equal to negative 3x plus 6. And then I'll divide both sides by 2. So now I have y is greater than or equal to negative 3/2 x plus 3. Okay. Now this should be easier to graph now. So we'll draw our y-axis and our x-axis. We have a y-intercept of positive 3. And our slope is down 3 over 2. So 1, 2, 3 over 2. And I like to have 3 points. So then I'll go up 3 and over 2. Now this is a greater than or equal to, so I will draw a solid line through these points. Okay, so this was step 1. Step 2 is graphing it, and our third step is to figure out the shading. So we test out a point. I recommend trying out 0, 0 and plugging that into our inequality here. So that would give us 0 is greater than or equal to 3. Now that's not true, so what we end up doing is we end up shading the area that doesn't have that, because 0 is not greater than 3, nor is it equal to 3. So we shade in this area right here. And those are the main 3 steps. We want to write this in slope-intercept form, we want to graph that, we want to be cognizant of using solid lines or dotted lines, and then we want to pick a point, preferably 0, 0, I think it makes our life a lot easier, and figure out which side to shade. Okay, now that we are able to graph inequalities based off of the written inequality, let's see if we can write an inequality for a graph. So let's look at example A. So for example A, we are given a few pieces of information. We know a y-intercept, which here if we count 1, 2, 3, 4, is going to be 0, 2. And we are also able to find a slope, because we can count from one point to the other. So right here we go down 2, so we know we have a negative 2. That's our rise. And then over 6. So our slope is change in y over change in x. So we have negative 2 over 6, or negative 1/3. Now if we know a slope and we know the y-intercept, we can write this in slope-intercept form. So we can write this as y, now we don't know whether it's less than or greater than. Our slope is negative 1/3 x, and then we have a plus 2. So now we have to determine whether it is less than or greater than. So we want to use the same strategy. I would pick this point 0, 0, and then imagine what would happen if we plugged it into this equation. So I'll do a little arrow and do the work here to the right. Well, if we had 0 and then question mark, 1/3 times 0 is just going to be 0 plus 2. Well, what is the relationship between 0 and 2? Well, we know 0 has to be less than 2. And that's actually the part that's shaded in here. So we're going to write y is less than negative 1/3 x plus 2. Alright, let's try part B. So for part B, similarly, we're given our y-intercept as 0, negative 2, and we're able to find the slope. So we just count up 1, 2, 3, 4, 5. So positive 5 over 1. So our slope is 5. So now we have y, and then I'll write a question mark here, 5x minus 2. So once again, I want to test out a point. We'll test out 0, 0. And we know that 0 and minus 2, 0 has to be greater than minus 2. So our inequality is y is greater than negative 5x minus 2. So when you're doing this, it's important to pick a point that is easy to work with. I mean, you could get the answer to this by plugging in 12 and 27, but 0, 0 is usually a good place to start for these. Alright, well that's going to be the end of the video for today. I hope this was helpful. Take care.